2008 Grade 11 Hypatia Math Contest. For numbers a and b, the notation a symbol b means 2a plus b squared plus ab. For example, 1 symbol 2 is 2 times 1 plus 2 squared plus 1 times 2, which is 8. Determine the value of 3 symbol 2. Well, according to that definition, that would basically be 2 times 3 plus 2 squared plus 3 times 2, and that is equal to 16. If x symbol negative 1 is 8, determine the value of x. So that means 2x plus negative 1 squared plus x times negative 1 is equal to 8. So expanding, this is 2x plus 1 minus x is 8. And when you solve for that, you basically just get x equal to 7. If 4 symbol y is 20, determine the two possible values of y. So again, according to the definition, it would be 2 times 4 plus y squared plus 4 times y, and that's equal to 20. So if you expand this, you get y squared plus 4y plus 8 minus 20 is 0. So that means y squared plus 4y minus 12 is equal to 0. And I think this factors very nicely. It factors 2y, 6, 2 plus negative. So therefore y is either minus 6 or positive 2. And finally, the part D, if w minus 2 symbol w is 14, determine all the values of w. So again, according to this definition, it would be 2 times w minus 2 plus w squared plus w minus 2 times w, and that is equal to 14. All right, so we just have to solve this. So this is 2w minus 4 plus w squared minus 2w minus 14 equals 0. Collect like terms and we get 2w squared, and then this cancels with that, and that's going to give me 18, right? So w squared is 9, therefore w is plus or minus 3. Determine the equation of the line that passes through 7, 8, and 9, 0. Well, the equation of a line is y equals mx plus b. M is the slope, of course, and m is calculated as the rise over run. So the difference of the y values over the difference of the x values. And that, it looks like 8 over negative 2, and that, therefore, is negative 4. So my equation is minus 4x plus b. To figure out the value for b, substitute either one of those points. Doesn't really matter which one. I'll put in 9, 0. So when this is 0, that means that x is 9. So that means b is 36. So the equation is y is equal to minus 4x plus 36. Part B, determine the coordinates of P, the point of intersection of y equals 2x minus 10, and the line through AB. Well, the line through AB is this. To get the point of intersection, you just have to set those two equal to each other. So 2x minus 10 is equal to minus 4x plus 36, and then solve for x. So this is 6x is 46, so therefore x is 46 over 6, which in lowest terms is 23 over 3. Sub this back into either one of these equations, either this one or this one, and when you do, you get y is equal to 2 times 23 over 3 minus 10, and that is 16 over 3. So that point P that they're talking about is 23 over 3 for the x coordinate and 16 over 3 for the y coordinate. Is P closer to A or to B? Explain your answer. So if I can calculate the distance PA and then calculate the distance PB, whichever is shorter, that will be the answer. So P will be closer to whichever is shorter. So to figure out the distances, that's pretty straightforward, right? Because we have A and B right up here. So A is 7, 8, B is 9, 0, and P is 23 over 3 and 16 over 3. All right, so that should be pretty easy. Using the distance formula, PA is going to be 7 minus 23 over 3 all squared plus 8 minus 16 over 3 all squared, and under the square root sign. And when you do this math, it's 68 over 9. Square root, of course. And then PB, using the distance formula, 9 minus 23 over 3 all squared plus 0 minus 16 over 3 all squared under the square root. And when you crunch out these numbers, it's 272 over 9. So obviously this one is bigger. So that means that PB is greater than PA. So that means that P is closer to A. In the diagram, ABCD is a trapezoid with AD parallel to BC and BC perpendicular to AB. AD is 6, AB is 20, BC is 30. Determine the area. Well, in any trapezoid, let's say you have a trapezoid like this, and this is A, this is B, and this is the height. The area is calculated as A plus B divided by 2 times the height. So use the same formula up here. So ABCD, I guess, that's going to be 6 plus 30 divided by 2 multiplied by 20. And when you calculate this, it's 360. Part B, there is a point K on AB such that the area of triangle KBC equals the area of quadrilateral KADC. Determine the length of BK. All right, so somewhere on AB, there's this K. So I don't know where it is, so I'm just going to guess it's there. And they're saying that the triangle KBC, so this triangle right here, so let's write it out here, triangle KBC equals the area of quadrilateral KADC. But KADC is basically the full trapezoid, which is ABCD, minus that triangle KDC, right? KBC, sorry, not D. So I guess this is what we have to figure out. If you bring this guy over, this becomes 2 of triangle KBC equals ABCD. But ABCD we just figured out was 360. So that means that area of KBC is 180. Okay. That is somewhat helpful. What are we trying to figure out again? The length of BK. Okay. So triangle KBC is 1/2 base times height. The area. Well, base we know is 30. And the height is BK. Okay, I got it. Okay, so then this just becomes BK is equal to 180 over 15, right? So what's that? 180 over 15 is 12. Yeah. So that's it. 12 is the answer. Great. There is a point M on DC such that the area of triangle MBC equals the area of quadrilateral MBAD. Determine the length of MC. Okay. So let me draw this again. I don't want to make it too messy. And so something like this, right? Yeah. So let's just label it A, D, B, and C. And this time they're saying that there's some M here that when you draw that triangle, then the area of MBC, that triangle, is equal to the area of ADMB, right? MBAD, right. MBAD. Okay, well, MBAD is basically just the trapezoid ABCD minus this triangle MBC. It was very similar to the previous question. So that means that two of those triangles MBC is equal to ABCD, but ABCD we know is 360, so that means MBC is equal to 180. All right, so pretty much identical to the previous question. But again, what are we trying to figure out here? Trying to figure out something. MC, okay, MC. All right, so let me just write that here so I don't forget. MC is what we're trying to figure out. Okay, well, let's see here. I'm going to have to draw a height that's perpendicular. So, interesting. Let's just call that H for height. So 1/2 base times height is the area of MBC. The base is BC. And BC we know is 30, right? Yeah, from the diagram. And then we have H. Okay, so that means H would be 12. All right, this is pretty much identical to the previous question. Now we have to figure out MC, the hypotenuse. So how do I figure out hypotenuse? I think this is a similar triangle situation, because if you draw, yeah, this is similar triangles. Yeah. Okay, do we know DC? Did they give us DC? No, they didn't. Okay, so I'm going to have to work with others. So those two triangles are similar, right? Well, there's nothing labeled here, so I'll just draw it. I don't want to introduce any more variables. This triangle, right? And then this one. Those two are similar. So that means that this was 20, I believe. So that means 20. And let's see here. This side here, I don't know, so I'm going to label that something. Oh, but I do know. I do know because AD was 6, correct? Yeah, AD was 6. Okay, I got it. So since AD is 6, that is 24. Okay. So 20 over 24 is the equivalent of H over, I can just label this something, A, from here to here. And then this is what, 5 over 4. And then H we got 12 over A. Oh, sorry, 5 over 6. So that means a 5A is 72. Or 6 times 12 is, 72. And therefore, A would be equal to 14.4. Okay, great. So now to get MC, I guess we just use the Pythagorean theorem. So that's going to be MC is equal to H squared plus A squared. So MC squared is what's 12 squared plus 14.4 squared. So that is 351.36, and then if you take the square root to get just MC, it'll be 18.744 approximately. And that completes number C. Number 4, the Piazzi sum of a sequence A1 through AN is formed by adding the products of all the pairs of distinct terms in the sequence. For example, the Piazzi sum of the sequence A1 to A4 would be A1 plus A2 and so on. The Piazzi sum of the sequence 2, 3, x, 2x is negative 7. What are the possible values of x? All right, so we have these terms, 2, 3, x, and 2x. So we have to figure out, first of all, these pairs. So we have 2 and 3, 2 and x, and 2 and 2x. Then we have 3 and x, 3 and 2x, and x and 2x, like that. So we have 6, 2x, 4x, 3x, 6x, and 2x squared. And then if you add these guys up, it looks to me that's 2x squared plus 15x plus 6. And that, they're saying, is equal to negative 7. So that's what we have to figure out. All right. Okay, so this is a basic quadratic. I mean, you really should do it on your own, but I'll just do it since I'm a nice guy. All right, so first of all, let's set it all equal to 0. And this will be 13, right? Okay, use a quadratic. You can factor it probably, but I'm going to use a quadratic. So let's see here. 15 squared minus 4 times 2 times 13 all over 2 times 2. And therefore, this is minus 15 plus or minus 121 over 4. And that gives me negative 1 or negative 6.5. So there you go. Oh, sorry, this should have been under a square root. Yeah, got to make sure I don't forget the square root. Okay, so that takes care of part A. Now part B. A sequence has 100 terms. Of these terms, m are equal to 1 and n are equal to negative 1. The rest of the terms are equal to 2. Determine in terms of m and n the number of pairs of distinct terms that have a product of 1. Okay, so let's make a little table. We have value and count. So the value of a term, if it's 1, we have m of them. And if the value of a term is negative 1, we have n of them. And if the value of a term is 2, those are all the other ones. So since there's a total of 100, the count would be 100 minus m minus n. And then they're saying, how many of the pairs have a product of 1? Okay. A pair would have a product of 1 in the following scenarios. You choose 1 and then 1. That obviously has a product of 1. Or you choose negative 1 and negative 1. That has a product of 1. So these two scenarios are the ones that produce a product of 1. So we have to figure out how many of these. Okay, so first let's talk about this one. We have the first number, we want it to be 1. Well, how many 1s are there? Well, there's m of them. So we have m choices. The second number, we also want it to be 1. But we can't use that first 1, so we have only m minus 1 choices remaining. So this is sort of the total. But you have to divide this by 2 in order to get the actual distinct pairs, because there's the doubles. Like, for example, let's say I had, I think I showed you like A1, A2, A3. If I say find the distinct pairs, well, it'll be A1 and A2, A1 and A3, and A2 and A3. So just these 3. But what if someone said, what about A2 and A1? Isn't that a distinct pair? But it's the same as this. So if you were to use this method, it would basically be, for the first choice, you have 3, right? We have 1, 2, 3. For the second choice, you have 2. And 3 times 2 is 6. But then you have to divide that 6 by 2 in order to get 3. And that's why we have 3 distinct pairs. So just in case you're wondering why I have to divide by 2, hopefully this explanation helped. And here it's the exact same thing. You want the first one to be negative 1, so we have n possible choices. The second number, we also want it to be negative 1. We have n minus 1 choices. But then you have to, of course, divide by 2 to get the distinct pairs, because this overcounts. It basically double the number. So the total is this guy and this guy. So the total number of pairs that have a product of 1 would be this m times m minus 1 over 2, plus this n times n minus 1 over 2. And that's pretty much the answer. Part C. A sequence has 100 terms, with each term equal to either 2 or negative 1. Determine with justification the minimum possible Paisley sum of the sequence. Well, again, we have value and count. And let's see, not much here. If it's 2, we have, they just tell us that there's 100, so I'm just going to say there's m of those. And there's negative 1, then there would be 100 minus m, because we're not sure what the numbers are. Okay, and that's about it. That's all they give us. They don't give us much information. Okay, so we want the minimum possible Paisley sum. All right. Well, to get the Paisley sum, we have to actually figure out all the products. So we have to figure out, first of all, how many of each pair there are, and what each pair has a product of. So there's only, as far as I know, there's going to be only, 3 scenarios, right? You're going to have, the first number is 2, and the second number is -1. That's one possible scenario. That would mean a -2 for a product. Or you can have the first number is 2 and the second number is 2, which would mean a product of 4. Or you can have this first number is -1 and the second number is -1, but that would be a product of 1. So those are the only 3 products. Now we have to figure out how many of each. Okay. Before I figure out how many of each, because there's m's here, it might get a little abstract, I'm going to do a simple example. I'm going to say, let's say there was only 4 2's, 2, 2, 2, 2, and I'm going to label these 1, 2, 3, 4, just to kind of let you know that they're distinct. And then there's only 3 -1's. And again, I'll label them 1, 2, and 3. And I said to you, how many of these scenarios are there? Okay, well, for my first -1, I have 3 choices, any of these 3 guys. And then for my second -1, I have 2 choices. So there's 6. But remember, you have to divide by 2. So it's actually 6 divided by 2, which is 3. So same thing here. We have to now deal with this guy, 100 minus m. So it's not exactly the same. So it would be, for the first choice, which is this guy, it would be 100 minus m. But for the second choice, it's 100 minus m minus 1. And then, of course, don't forget to divide by 2. So basically, it's 100 minus m times, what is that, 99 minus m divided by 2. That's how many pairs there are that give a product of 1. Okay, so hopefully that makes sense. Now let's move on to this guy. And again, I'm going to give an example first. I want to know how many pairs are there that have this product. Okay, well, in this example here, I want my first number to be a 2 and my second number to be 2. For my first number, I have 4 possible choices. And for my second number, I would have only 3 possible choices. But remember, you have to then divide that number by 2 to get a 6. But this time, we're not dealing with 4, we're dealing with m. So instead of that 4, we put an m. And then for the second number, there's m minus 1 choices. And don't forget to divide by 2 to get the number of distinct pairs. All right, now finally, this guy here, this is a little bit different. And I think this is the part that might confuse people. So that's why I wanted to give this example. If I said to you, just in this example here, where there's 4 of those guys and 3 of these guys, how many pairs are there? Well, for the first one, where I wanted a 2, there's 4 possibilities. For the second number, which is what I wanted a -1, there's 3 possibilities. So it's 4 times 3, which is 12. And as you can see, that is a little bit different, right? Because you did not divide by 2 this time. So I want you to be convinced of that. So same thing here. It would basically be m times 100 minus m. Okay. All right. So now that we have all that, we can now calculate this Paisley sum. Paisley sum basically would be all the pairs that have a sum of 1. Okay, well, how many are there? There's 100 minus m times 99 minus m, all divided by 2, and each of them has a sum of 1. And then, of course, if the sums keep going, all the pairs that have a sum of 4. So that would be m times m minus 1 divided by 2, and they all have a sum of 4. And then add to that all the sums that have all the pairs that have a product of -2. I think that's the right way of saying it. So that would be m times 100 minus m, and all of those guys are equal to -2. So this is the math, basically. This is what we have to minimize. Okay, so I'll let you expand it all out, and when you do, you get down to this. When you expand and collect like terms, 9 over 2m squared minus 6 over 3 over 2m plus 4950. All right, so now this is what we have to minimize. Now remember, this is obviously a quadratic, and I have no idea what it looks like, but because this is a positive coefficient, I know that it opens up like that. And therefore, there's some point here where we get the minimum. At this point, it'll be at the minimum, so I'll just write min. And this point has a special term. It's called the vertex. And the vertex of an equation that is of the form y is equal to ax squared plus bx plus c, vertex is equal to, I think some of you may remember, minus b over 2a. So to get the vertex, all we have to do is use that formula. So vertex over here, minus b, so that looks like minus 603 over 2 times 9 over 2. And that looks like 603 over 2 over 9. So 603 over 18. And if you take out your calculator, it comes to 33.5. Great. So we got that this is 33.5 on the x-axis, or in our case on the m-axis. And then the Pasi sum, which is this axis, PS for Pasi sum, which is this value right here, we would have to plug this 33.5 into this equation. All right, so Pasi sum, and remember this is the minimum Pasi sum, which is what we want. Plug this into there, so it would be 9 over 2 times 33.5 squared minus 603 over 2 times 33.5 minus plus 4950. And then when you crunch out these numbers, you get a nice integer value of -99.